All right, so we got cut short with that one a little bit. We had two solutions for example 3, which was -1/2, and 3. Those are possible solutions. We said that -1/2 works, but we're going to check 3 as a possible solution and substitute 3 in for x. We have 2 times 3 over 3 minus 1 plus 1 over 3 minus 3 equals 2 over 3 squared minus 4 times 3 plus 3. And what we found was that we get 3 plus 1 over 0 equals 2 over 0. Well, these are undefined, and 3 does not equal an undefined solution. So it doesn't work for the original problem. So we say that 3 is extraneous, which just means it's an extra solution that we don't need, that does not work for the original problem. So our only solution is -1/2 in this situation. I'm going to leave example 4 for you to do. Following the same steps, you need the least common denominator, multiply every term by that denominator, and then you can have a factorable polynomial. Keep in mind that those solutions may or may not work for the original problem, and sometimes both or all the solutions that you find will work, sometimes one, sometimes none, and in that case there'll be no solution to the original problem. Okay, now we're going to spend a little bit of time on some word problems. Now everybody's excited about that. This is something from your science class. This is a mixture problem. And how I like to set them up is kind of a column here to help me just organize my data. So I have, it says how much pure 100% pure acid, means 100% of it, must be added to 50 milliliters of a 35% acid solution to produce a mixture that is 75% acid. So we have 35% plus, we're going to add to that 100% solution to get a 75% solution. So 0.35 and then that's going to be 1, and that's 0.75, and this is the amount of solution over here. Which in this case we have 50 milliliters of 35%. We want to know how much of the 100% we're going to get, and then if we add whatever we add to the 50 milliliter, let's, for instance, if I added 60 milliliters to that, that would be a total of 110. So I really don't know that x is 60, so I'm going to put 50 plus x. And then I can create an equation out of this. Going across, I'm going to multiply, and going down, I'm going to add. And what I would have then is a 35% of the 50 milliliter solution is acid. I want to add 100% to that, so that 1x, and then that's going to equal my 75% solution of the 50 plus x. There's really a couple of ways to work this out. One of them is a very basic algebraic method where we're going to simplify, get x on one side, your constants on the other, and solve for x. Another way is to use a graph and use the concept of equal functions, and where two functions are equal is where their graphs intersect. For this particular problem, 0.35 times 50 is going to be 17.5. Then we would have plus x, and that would equal 0.75 times 50 plus x. Now normally we would multiply that all out, But I'm going to do a little something different here and divide this side by 50x, and then this side by 50 plus x. I'm at 50 plus x over on the other side. And so that I have a function that says 17.5 plus x over 50 plus x is equal to 0.75. And this is kind of a little strange, but I'm going to treat the left side as one function, and we'll call that f of x. And I'm going to treat the right side as another function, g of x. And what I want to do is to use a graphing calculator and put the left side as one function and the right side as another function on the same graph, and we're going to see where those two values intersect. Alright, so I'm here in Desmos, and I'm going to graph the left side of the function. So we've got y equals 17.5 plus x. And then we're going to divide that by 50 plus x. And you can see that we start to get an equation. And then we're going to graph the other side, the right side, the g of x function, as y just equals 0.75. So it's just going to be a straight line. But what we want to do is look where those two functions intersect. Kind of have to scoot way over here on our graph. Hopefully that happens soon. We'll zoom out and see if we can find it a little bit quicker. I'm going to change my y-axis. So I can really see that intersection. And it shows me that it intersects at 80 and 0.75. What that tells me is that to get a 0.75%, I need 80 milliliters of solution. So that's how I use my graph to solve in this case. All right, so we found that for example 5, that to get a 0.75% or a 75% solution, we actually needed 80 milliliters of 100% acid, and that was found on the graph. Okay, so for our next one, we've got minimum or maximum perimeter, and what we're looking for is, again, we're going to look at a graph, and it says find the dimensions of the rectangle with a minimum perimeter if its area is 200 meters squared. So I'm going to draw a rectangle, and normally we think of it as length times width. We know that length times width is the area, and the area is 200 meters squared. And what I can do is, because I'm wanting to look at the perimeter, and in order to do this problem, I need to be in one variable. I'm going to divide by the width and get length is 200 over the width, and then that allows me to replace the length in the problem with 200 over W. So now I have the length and the width in one variable. And I want the perimeter of this figure. I know perimeter is 2 times the length. So the length was 200 over W plus 2 times the width, so 2W. If I do a little simplifying, I get 400 over W equals, or excuse me, plus 2W. And I'm going to use my graphing calculator, and I'm going to graph this function so that we can solve for W here, which is the width. And we'll also see values for the perimeter for the different widths as well. So we're going to put this in our graphing calculator and we'll see what happens. All right, so I'm going to put my equation into Desmos, and I get y equals, y is going to be my perimeter here since I only have x and y to work with. Y is my perimeter, equals 400 over x plus 2w, or plus 2x in this case. So x is going to be our width. At first glance, it doesn't look like we have anything. We're going to have to zoom out until we see part of the graph. Okay, so now we can see some of our graph, and we're looking for a minimum value. So we're looking where we have a trough in the graph where it goes down, and this tells me that my x was my width. So it says my width needs to be 14.14, and my minimum perimeter then would be 56.57, and I believe that was in meters. So this would be my width, this would be my minimum perimeter. I'm going to leave question number, or example number 7 for class on Monday. It's kind of an extensive problem, and we're going to also come up with an equation and graph an intersection to get the solution for that one as well. So we'll do that one on Monday, and you have a few problems to work on, and that's going to be found in Interact Math this time. So